I'm glad that you make it to this lecture, and I want to welcome you. My name is Siim Lund, and I'm an author, a biohacker, a speaker, and just like a self-experimenter. And I don't have specifically a degree in epidemiology or virology or anything like that, but I do have like a bachelor's degree in anthropology. So I'm used to doing my own research, and I understand the scientific literature, and I've also written several books about ketosis, intermittent fasting, autophagy, and other topics related to biohacking and becoming like a stronger human being. So I have my skin in the game, and I do kind of hope you to give us some valuable information. So the purpose of this lecture is to just explain how you could use something like intermittent fasting and time restricted eating to strengthen your immune system and to just become healthier, fitter, lose some weight, improve your body composition, and yeah, just become stronger as a human being. First of all, we're gonna look at how does fasting affect the immune system. Is it any good at all? How you should fast during these times and at other times. What is autophagy? How is autophagy working in the immune system? What kind of viruses have been shown to be benefit from autophagy and fasting, and which ones not? Because it's not like this black and white answer. Some of the viruses actually use these mechanisms to replicate themselves, and some of them don't. Some of them they get wiped out. So it's a very context dependent situation. And the only thing we can do, like we don't have any specific studies on these current pandemic and these current viruses that we're dealing with, but we can just look at the data that we have from the past and kind of try to draw some more conclusions. So there is nothing here is like medical advice, nothing here is definite. It's all kind of subject to change as we get more research. But the least we can do is to just educate ourselves about how the body works and what kind of a research that we have currently. So yeah, fasting itself is a really popular topic at the moment. A lot of people may think that it doesn't really make sense to not eat and especially during time where you're maybe more susceptible to catching some sort of a cold. But actually, fasting, or at least not eating or reducing your food intake, has been shown to be quite effective in treating various kinds of illnesses. And fasting is like a ancient type of healing practice that's been practiced by virtually every culture and a society. And even if I'm not mistaken, then Hippocrates said that if you eat during your sickness, then it's basically the equivalent of feeding the sickness. There's also some research that shows that you may lose your appetite and you begin to eat less during the first few days of illness. It's the body's natural response to fighting the infection that can be seen in humans as well as insects and other animals. So when animals do get sick from something, then they naturally just stop eating. And this is called infection-induced anorexia, which which is a funny term, but science has found that this is more very like an evolutionary viable strategy because it's kind of preserve energy and it allows your body to focus on self-healing. So instead of giving yourself calories and energy to feed the illness, you're essentially starving it out, and it promotes this process called programmed cell death or apoptosis. And apoptosis is almost like a suicide of the cell. The cell is going to suicide, and it's going to kill the infectious agent with it. Apoptosis is somewhat different from autophagy, which we're going to talk about later. But basically, autophagy is cell recycling, and it doesn't destroy the cell completely. It only recycles some of the kind of dysfunctional and infectious particles, but not the entire cell. We're going to talk about it later. Research does show that fasting in general can affect the immune system in a positive way. Not only does it protect against immune system damage, but also helps to induce its regeneration. Fasting boosts your immune system by lowering inflammation and oxidative stress, and one of the bigger collateral damage that occurs during any kind of infection or illness is the high amounts of inflammation and stress that the body kind of creates as a response to the illness. Inflammation and high amounts of stress are basically implicated in all diseases, and it does cause more damage to the healthy parts of the body. And fasting helps to kind of keep things in check. It's going to lower oxidative stress, and it's also going to activate many of the body's own antioxidant defense systems like glutathione, autophagy, and many others, NR2. So fasting is like anti-inflammatory and a very low oxidative stress environment because you're cutting away the kind of potential source of the oxidative stress, which in most cases is just food and calories. Fasting also increases mitochondrial functioning, which is going to strengthen your cellular functioning in general. So mitochondria are the powerhouses of the cell that produce energy, and you need well-functioning mitochondria to stay optimal and stay healthy. It's been found that 48-hour to 120-hour fasts reduce pro-growth signaling and enhance cellular resistance to toxins. This is going to inhibit mechanisms of cell replication and directs resources towards hunkering down. So it's going to decrease the potential of spreading infections, and it's again promoting kind of starving out the the malignant cells or the cell particles, because if you don't have like extra energy circulating in the system, then it's also going to just prevent replication of any kind. It's going to prevent the replication of healthy cells, but it's also going to prevent the replication of like bad cell particles, including viruses. Next, fasting recycles damaged immune cells and reverses immunosuppression. So it's going to trigger cell regeneration by activating stem cells. And stem cells are these universal cells that begin to swap out all the old and worn out cells that are damaged, and they kind of reinvigorate the entire body. So fasting boosts stem cells or activates them, and this in turn can regenerate the immune system, regenerate cellular functioning, and just has like anti-aging and longevity boosting benefits. So even if you are killing off some cells with apoptosis or something like or autophagy, then the stem cells can be used to replenish them. One study in particular, done by one of the leading researchers of fasting, Walter Longo, showed that you can reset your immune system by fasting. Mice and chemotherapy patients who didn't eat for several days saw a significant reduction in white blood cell count. This then turned on signaling pathways for hematopoietic stem cells, which are responsible for the generation of blood cells and immune system. And after you start refeeding, the blood cells come back. Walter Longo said, quote, "When you starve, the system tries to save energy, and one of the things it can do to save energy is to recycle a lot of the immune cells that are not needed, especially those that may be damaged." End quote. The white blood cells get broken down as a means of throwing away unnecessary material. This study shows that extended fasting has a profound impact on the way your body can heal and strengthen itself. And next up, fasting activates autophagy, which is going to recycle old and weak cell components back into energy. Autophagy has a very important role in shaping immune system development, fueling the host's immune responses, and directly controlling intracellular microbes as a defense system. For a little bit of background, autophagy is also the critical component for anti-aging and lifespan extension seen in calorie restriction. For example, mice and yeast that are defective in autophagy don't live longer despite consuming fewer calories, whereas having sufficient autophagy allows these effects to take place. Deficient autophagy has been shown to promote aging as well as all kinds of diseases, and autophagy is required to fight age-related muscle loss, promote insulin sensitivity, getting into ketosis, managing the immune system, and removing aging mitochondria. Different kinds of stressors can activate autophagy, but the key component or the key factor is nutrient deprivation and energy stress. So the body has to be kind of stressed out in a way to have a reason to activate autophagy. And one of the top ways of doing so are exercise, taking a sauna, fasting, and even hypoxia, cold exposure. All of these hormetic stressors, so to say, that these stressors that have like a positive and net benefit on the body and that make the body stronger. Next up, fasting also promotes sirtuins, which are another longevity related proteins. And sirtuins translate into silent information regulators, and they kind of basically turn on or off certain genes related to DNA repair and longevity. So higher amounts of sirtuin activation is associated with more longevity and lifespan extension in different species. And people who also consume like diets rich in sirtuins, such as like different kinds of dark pigment vegetables and berries, and even red wine. It has sirtuins, and they also tend to show greater longevity. But you can also get the same effects from just fasting and kind of stressing your body out from the nutrition. It's also found that sirtuins are evolutionarily conserved viral restriction factors. Sirtuin activating drugs have been shown to inhibit replication of influenza A and cytomegalovirus. Fasting and dark pigment polyphenols stimulate sirtuins. Hormesis has been shown to strengthen all parameters of the immune response. It's a dose-specific stressor that makes the body stronger in the future. Fasting and not eating are physiological stressors that in the right amounts will strengthen the entire body. So, as you can see, fasting can be very beneficial for the immune system, but only if you take it in the right amount and if you don't overstress your entire body. But what about specific viruses? Because, all kinds of infections, there are different kinds of infections, different kinds of viruses, different kinds of pathogens, and they're not universal in a way. Your body isn't going to respond to them in the same way. So it always depends on the particular infection, depends on the particular person, and what kind of other things do they have going on in their environment at a particular moment. So let's look at from research what kind of viruses have been shown to be eliminated by fasting or not. Fasting for 24 hours enhances the replication of oncolytic herpes simplex virus in glioblastoma. Oncolytic viruses are viruses that kill cancer cells so they can be therapeutic. In mice, fasting for 48 hours modestly increases hepatitis B virus. However, that would be the equivalent of fasting 3 times longer in humans. Intermittent fasting exacerbates the acute immune and behavioral sickness to the viral mimic poly-IC in mice. IF increased the expression of neuropeptide Y in the hypothalamus and plasma corticosterone. There's some research to show that you may lose your appetite and begin to eat less during the first days of illness. Infection-induced anorexia, as it's called, is an evolutionarily viable strategy, as it preserves energy and allows to focus on self-healing. This also prevents feeding the infectious agent and promotes programmed cell death or apoptosis. It's the body's natural response to fighting the infection that can be seen in humans as well as insects. A Yale 2016 study found that fasting is protective in bacterial but not viral infections. They infected mice with the bacterium Listeria monocytogenes, which causes food poisoning. The mice stopped eating and eventually recovered, but force feeding increased their mortality. What's more, giving them glucose led to fatal reactions, whereas proteins and fat didn't. Inhibition of glucose is protective against endotoxemia. They also found that inhibiting glucose utilization was lethal in influenza infections, which is a virus. The mice died when they were denied food. However, your body can also produce glucose while fasting by breaking down fat or protein, so you're never really fully deprived of glucose. The Yale study concluded that cells need ketones to lower bacterial inflammation, whereas glucose is preferential for responding to unfolded proteins during viral inflammation. However, your body can also repair unfolded proteins with things like heat exposure, sauna, and exercise. These activities also make the body create its own endogenous glucose through gluconeogenesis, so you're never really fully deprived of glucose even while fasting. There's an old saying, feed a cold, starve a fever. One study found that nutritional status regulates T cells and inflammation. Eating increased gamma interferon, which is a protein that fights infections, and fasting stimulated a release in an inflammatory cytokine IL-4. So, as you can see, fasting can be beneficial in some cases, but in other cases it might not be. Generally, I would say that the length of the fast is also quite important because there are different kinds of fasting methods. They're different. They have different lengths. They last different amount of time, and they're gonna have a different effect on the body as well. So, for example, fasting for 16 hours isn't gonna nearly activate as much autophagy, and it's not gonna cause that much stress as fasting for 3 days. There's a drastic difference between them, and fasting for only like 16 to up to even 24 hours, that's considered like a short daily time restricted eating window. It's a short fast, and that's something that you can do basically every day, The benefits of this include just like a slight increase in basal autophagy, but not too much, and better blood sugar regulation, lower inflammation, more satiety, and losing weight potentially if you undereat calories. So a short daily fast is something that I think isn't gonna like kill a virus, and it's not going to promote the growth of a virus either. It's not going to replicate a virus. Versus something like a 3 day fast, then this potentially that's going to just increase autophagy. It's potentially going to activate apoptosis. It's potentially going to trigger stem cell regeneration, and it essentially has like a stronger effect in terms of activating all these pathways related to anti-aging and longevity. So on a 3 day fast, you probably will see higher amounts of autophagy, and it will also probably, uh, you know, in so doing, eliminate more amounts of different kinds of pathogens. But it's not like definite. It may not do so. So I wouldn't like place my bets on any kind of fasting. And specifically, the process of autophagy isn't a black and white answer either. Some of it is good and some of it is bad, depending on the situation and depending on the infection. Autophagy's role in immunity is called immunophagy. It functions in both the innate as well as the adaptive immune system by regulating thymic function, presentation of antigens, lymphocyte homeostasis, T cell regulation, cytokine production, control of inflammation, and survival. Deficient autophagy weakens immunity and increases risk of other pathologies like heart disease, cancer, and aging. However, as a result of the evolutionary arms race, viruses can evolve to hijack autophagy and use its mechanisms to survive and replicate themselves. The process of degrading foreign microbial invaders is called xenophagy. It describes the breakdown and degradation of bacteria as well as viruses by autophagy. Virophagy is the autophagy of virions. Both of them can promote the elimination of infectious agents, but they can also be subverted by several viruses. So now let's look at how does autophagy affect the immune system, especially how does it respond to bacterial infections and whether or not it's beneficial. Bacteria like Streptococcus pyogenes or pathogens such as M. tuberculosis, Salmonella, and Listeria monocytogenes can be eliminated by autophagy. Autophagy can protect host cells against toxic products generated by pathogens such as Vibrio chlorella cytolysin, Bacillus anthracus lethal toxin, and H. pylori. Viruses that escape or block autophagy include herpes virus, HIV-1, human cytomegalovirus, and Coxsackie B3, B4. Influenza A virus can also use autophagy to replicate itself. Several studies have shown that coronavirus infection induces autophagy. However, the pathway doesn't appear to be required for replicating the virus. So autophagy is probably acting as a cellular defense to the virus infection. Your body is just responding to the virus by trying to eliminate it with the involvement of autophagy. Autophagy has been shown to be beneficial against the similar coronaviruses in the past, such as SARS, that happened around 2003, as well as MERS, which happened a few years later. There is no specific data about recent coronaviruses, but it does show some potential. I think it's very hard to tell whether or not autophagy or fasting are going to specifically be beneficial for this particular coronavirus, COVID-19 or SARS-2. So because we don't have any research about it and no one knows, no one has any tested it, but we can only look at the past research and we can only kind of make some conclusions from the general principles of our physiology. However, autophagy does play a role in like respiratory infections as well as just promoting respiratory health, which is kind of a critical component to surviving, let's say, for this example, the COVID-19 virus. Autophagy plays an essential role in the inflammatory response of the lung to infection and stress. It inhibits inflammation and mediates the response of leukocytes to infections. Defective autophagy leads to the accumulation of reactive oxygen species. Autophagy removes aggregated inflammasome structures, thus dampening the pro-inflammatory response. At baseline, autophagy may be critical for inhibiting inflammation and infection in the lung, but it can also damage lung epithelial cells if expressed excessively. Inhibiting autophagy causes lung inflammation in cystic fibrosis. Stimulating autophagy with rapamycin lowers lung inflammation and infection in cystic fibrosis. Autophagy eliminates infections and macrophages in the lung caused by cigarette smoke. defective or deficient autophagy in the lung leads to the accumulation of autophagosomes, protein aggregates, dysfunctional mitochondria, and bacteria, which promotes infections. Sufficient autophagy, on the other hand, prevents that and can decrease infection rates. Autophagy inhibits tuberculosis survival in infected macrophages. It's a defense mechanism against Mycobacterium tuberculosis. In other cases, tumorigenesis in tuberous sclerosis complex is autophagy dependent, and inhibiting autophagy kills it off. So, in conclusion, I have to say that fasting can be beneficial for you. It can strengthen your immune system, but at the same time, it can also potentially replicate some viruses if it becomes like an overbearing stressor. And generally, if you're only fasting the shorter fasting window, like 16 hours, 12 hours, 14 hours, 20 hours, 24 hours, then that shouldn't be a problem. And that's something actually you could do on a daily basis to kind of upregulate autophagy and keep your immune system stronger. But at the same time, currently, I wouldn't go for longer fasts that last for longer than 2 days, 3 days, because during the fasting window itself, your immune system actually gets weaker in the short term, and it will bounce back, but it may be too late at that time. So generally, it's better to stick to the shorter fast and not try to overstress your system with a longer fast, at least for the time being. If you're already pretty healthy and you have a strong immune system, then it's partly because of autophagy, and at that point, autophagy will also help you to maintain that resilience. However, if you're sick very frequently and you tend to have a weak immune system, then it's partly because of insufficient autophagy or defective autophagy. If you're already sick, then whether or not autophagy is going to help you depends on the particular disease and how severe it is. A mild infection can be probably eliminated quite rapidly if you catch it fast, but if you're severely sick, then autophagy could make things worse. Alright, that's it for this, my lecture. I hope you get some valuable information from it. And in conclusion, again, this is not definite. This is just the research that we currently have and the research that I've done. So yeah, hopefully you got some valuable information from it, and I'll see you maybe in the future.